Hello everybody, we are going to be learning about how to find zeros, critical points, and increasing and decreasing intervals. So yours is a smaller foldable, mine is just bigger, so we can see what I'm writing a little bit easier. All right, let's get started. Finding the zeros and y-intercept algebraically. To find the zeros, set f of x, the entire quantity of f of x, equal to 0, and then solve for the value of x. What is this saying? Well, it's basically saying set y equal to 0, meaning that there is no height on the graph. If there's no height on the graph, that means it's going to lie somewhere right there. And so we're going to plug in 0 to get on that line, and it'll tell us where does our function hit the x-axis. To find the y-intercept, we do the difference. So we're just going to be kind of the same idea, but we're saying, hey, when is x equals 0, we're going to find y. So x equals 0 everywhere on this line. So if we plug in x equals 0, we can figure out where does it pass through the y-axis. All right, let's get started. These are probably easier than you're thinking. So let's start with finding our zeros. We're going to set f of x equal to 0. 0 equals negative absolute value x minus 5, absolute value plus 3. So let's solve through this. Put a minus 3 on both sides. Get negative 3 equals negative absolute value x minus 5. We want to isolate the absolute value, so I'm going to make this, which was a negative 1, I'm going to divide both sides by negative 1, which gives me 3 equals absolute value x minus 5. Now, to solve it from here, we need to do this two cases. Case 1, where it's 3 equals x minus 5, and then we'll do case 2. Where it's negative 3 equals x minus 5. And we'll solve from there. Add 5 to both sides. We get x equals 8, or x equals 2. This tells me that this function is going to pass through the x-axis at 2 and 8. Alrighty, let's find the y-intercept. Y-intercept, all we're going to do is plug in x equals 0 and solve for y. So remember, this is what our y is. We're going to go negative 0 minus 5 plus 3. We're going to solve through that. 0 minus 5 is negative 5. The absolute value of negative 5 is just 5, but then we have to bring down that negative, making it a negative 5. So this is going to be negative 2. Our y-intercept is at negative 2. All right, next one. For this one, we want to simplify it before we begin, so I'm going to go ahead and factor this. Best way for this one would probably be the AC method, which would be 2 times negative 4 gives me negative 8, and I'm trying to think of two numbers that add to negative 8. Sorry, multiply to negative 8, but they add to negative 7. So that would be negative 8 and positive 1. Remember that this method is just creating two values that equal that, but it's going to let us do grouping now. I can factor out a 2x from both of these. And this one, I don't need to factor out anything. If anything, I can factor out a 1 and get x minus 4. Since they both have this x minus 4, it tells me I'm doing this correctly. I got a 2x and a plus 1. And x minus 4. All right, let's find our zeros. Zeros say, oops, I don't know why I put a 0 there. The zeros tell us to set the whole thing equal to 0. So I can do ZPP, zero product property, because if both of these multiply to give me 0, then each of these has the possibility of being 0. So I'm going to let it be 2x plus 1 equals 0, or x minus 4 equals 0, and we're going to solve. Minus 1 on both sides, we get 2x equals negative 1, divide by 2, x equals negative 1 half, or if we add 4 on both sides, we get x equals 4. Okay, so this tells me it passes through my x-axis at these two locations. Let's find our y-intercept. We do this by plugging in 0 for anywhere we see an x. So you could write it like, I'll try that again. F of 0 equals all of that, but wherever you see an x, put a 0 instead. This is nice because 0 squared times 2 is just going to be 0. 0, bring down your minus 4, and you get negative 4. So f of 0 equals negative 4, meaning it's going to pass through my y-axis at that location. Next one. Again, I want to factor if I can, so it looks like they could all be, well, they all have an x, so I can pull an x out by the greatest common factor. I also notice that this one can be our product sum. What two numbers multiply to negative 7, but they add to negative 6? Those numbers would be negative 7 and a positive 1. Okay, so now we need to set all of this equal to 0. And we're going to do ZPP. And set everything equal to 0. 0 equals x, 0 equals x minus 7, 0 equals x plus 1. X equals 0, already solved. If we move this 7 over, we're going to get x equals positive 7. If we move this 1 over, we're going to get x equals negative 1. So in this function, it's going to pass through the x-axis 3 times, which we haven't seen much of, but this one has a power of 3, which tells me my function is going to look something like that. So you can imagine that the x-axis cuts through it 3 times. Kind of like a sea monster going out of the ocean. Okay, so that's our zeros. Let's do our y-intercept, same as before. We're going to set all of our x's to 0. In this case, they all 0 out, so we get 0 for our answer, telling us that it's going to pass through the y-axis at 0. Last one. I can't factor much of this, so I'm just going to go ahead and go straight to zeros. I'm going to move the 2 over, want to isolate that radical. I'm going to raise everything to the power 2 because that's the opposite operation. If I subtract 1 on both sides, I get x equals 3. This tells me that's going to pass through that function at x equals 3. Okay, y-intercept. So to find the y-intercept, I'm going to take the square root and plug 0 in for x, and then I'm going to solve through. So square root of 0 plus 1 is square root of 1 minus 2. The square root of 1 is 1 minus 2. You might be thinking, isn't it plus or minus? Well, the problem with this one is it's saying it's a function, so we're going to ignore the negative value. You don't need to worry too much about that, but the function technically looks like this. But since in the directions they told me that these are all functions right here, that means I have to ignore all these negative values, otherwise they're going to fail the vertical line test. Not a big deal. But the square root of 1 is just going to be 1 for this case. 1 take away 2 is negative 1, which tells me that for this function, it's going to pass through the y-axis at negative 1. Critical points are where the graph changes its direction or shape. Extrema points are where the graph changes direction. The function has a minimum or maximum value, relative or absolute at these points. A point of inflection is where the graph changes its shape. So critical points are either extrema or points of inflection. So this maximum here and this minimum here, those change its direction. So it's traveling from left to right. We always read graphs from left to right, like you're reading a textbook. It goes up, 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 and then all of a sudden at that point, it changes direction. Down, 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 and then it changes direction. It's different than a point of inflection because this is not a maximum or minimum, and it doesn't make it go up, but all of a sudden it's not a downward parabola anymore, but all of a sudden it's turning into a cubic function. So it's changing its shape or changing its parent function. And you should know about relative and absolute extrema. Yes, these are both points where they change direction, but this one is the tallest or the highest, therefore it's the absolute. But this one's a relative maximum because just amongst everything around it, it's the highest point. Same thing with over here. This one's still a minimum, but it's a relative minimum. Like, are you really low? Well, relatively. Around my points around me, I'm low because everything around me is higher than I am. But this one is the absolute minimum because it's the lowest one on the graph. Don't worry about these four. We're going to do them in class tomorrow because we need a graphing calculator, and I need to explain that to you in class. Moving right along. So we want to move from left to right whenever we read functions, and we're going to be doing interval notation. Increasing, constant, decreasing. So increasing, it's like you're reading uphill. Constant, meaning it's flat. And decreasing, it's going downhill. So let's get started. It's increasing. I'm going to highlight everywhere I think it's going uphill. We go from left to right, so it's climbing up this way. It looks like since there's an arrow on the end, it's going from negative infinity, wherever that starts, all the way over here. It's consistently climbing upward until this point. Whenever we do intervals for increasing or decreasing, you're going to be using your x values. So this x value is at -1. I can't touch infinity. Now, yes, there's a closed circle here, but it's tricky because you are going uphill, 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 and then you stop here. If you were to stand on this point, would you be going uphill or downhill? Well, you wouldn't be doing either of those. You'd just be chilling at a point. Since this point, as itself, does not increase or decrease, we're not going to include it. Okie doke. Moving forward. Then we're going to go flat, and it looks like it's from -1 all the way to +4. Again, at -1, it's neither increasing or decreasing, so we put parentheses. And same thing with that 4. And now decreasing. Decreasing, when is it going downhill? I don't have any more colors, so I'm just going to shade it in this way. So downhill, it's going from 4, well, there's an arrow there, so it's going to go to infinity, positive infinity. Can't touch infinity, it gets a parenthesis. It's not increasing or decreasing at 4, so I'm going to go ahead and give it a parenthesis. Okay, let's talk about more graphs. Increasing intervals. Well, it looks like it's going uphill right here. It starts at x equals 3, and it goes on forever to infinity. Decreasing. It is decreasing, going downhill from negative infinity all the way to that positive value of 3. Now these ones are tricky. If you read from left to right, and you just take your pencil and you follow along the graph, it's traveling, 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 and it's going down, 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 down. It goes down forever. Then you have to pick up your pencil from down here and go to the top and continue. It goes down, down, down to the right. So this one is always decreasing. It never has anything increasing, because if you're reading it from left to right, your finger will always go down as you trace over it. So increasing intervals, none. But decreasing, that's just about everything. But there's this zone right here where it's getting really close, but never gonna touch it. So we're gonna write negative infinity all the way up to this point, which is 1, 2, 3, 4, 5, negative 5. And then it picks up again from negative 5 to positive infinity. Increasing versus decreasing. Follow it with your finger from left to right. It looks like it's going uphill forever. So from negative infinity to positive infinity, it's been increasing. It doesn't look like it goes downhill at all, so there is none for the decreasing intervals. When it comes to these remaining ones, we're going to do these in class because we need some graphing technology. Cool. Thanks for watching, guys. See you tomorrow.